Today we turn our attention to finding derivatives of trig functions. And if we are given the figure over here at the right, which is the sine of x, let's try that again, sine of x, then let's graph the derivative of that. And if I'm going to graph the derivative of that, I am going to find places where the slope is 0. Slope is 0 at these places, and I'm going to make sure that the derivative has a value of 0 at those places. And then I'm going to notice that the derivative in this interval would be positive, and the derivative or the slope would be negative, and the derivative or slope would be positive, negative, and positive. And so I would draw positive values approaching this 0, negative values which return to 0, positive returning to 0, and on and on. This is what my derivative of sine would look like. Now what does that look like to you? And what do you know that starts at 1, and then by pi over 2 becomes 0, by pi becomes negative 1, 3 pi over 2 becomes 0, and if you're saying that the derivative of the sine of x is equal to the cosine of x, you are absolutely correct, and you know your first trig derivative. Now, does that mean that the derivative of cosine is sine? Well, here is sine of x. And let's do the same thing. Here's pi right here. Here's 2 pi. And pi over 2, 3 pi over 2. Now, it looks as if we start out with a slope of 0. So let's give the derivative a value of 0. And it looks like there's a slope of 0 right here, so we'll have a derivative of 0. And again, at the end, it appears as if the slope may be 0. So the derivative has a value of 0. In this interval here, it looks like the slopes are negative, or slopes are positive. So I guess I'd have to be negative, return to 0, be positive, and return to 0. And is that the sine of x? Well, here is the sine of x. And as I look at the sine of x, I was just making sure the recorder is still working after little blips. And no, sine doesn't start by going down and then up. Sine starts by going up and then down. And so the derivative of the cosine of x is not the sine of x. It's actually the opposite of the sine of x. And so now we know 2 trig derivatives. There are 4 in all that we will need to know. We'll talk about what the other 2 are. So we need to know derivative of sine, derivative of cosine, and 2 others. Find the 27th derivative of cosine. Sounds like something Mr. Amundsen would ask. Well, I know that if I've got a function, cosine of x, and I find the first derivative, we've just found that that is the negative sine of x. And the derivative of the second derivative, or the derivative of sine, coefficient come along for the ride. Derivative of sine is cosine, as we have just learned. Third derivative. Well, coefficient come along for the ride. Derivative of cosine is negative sine, which turns this into a positive. And the fourth derivative is cosine. So we're back to where we started. So the derivative of cosine would be sine, so this would be the 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th. And if we kept going, this would be every multiple of 4 down here. This would be the 24th derivative, which means this would be the 25th, 26th, and 27th. When you're asked to find 27th derivative, 105th derivative, whatever it might be, notice a pattern. There will always be a pattern. You'll never really have to find 27 derivatives. Derivative of the tangent of x. Well, let's see, tan x. It's another way of thinking of tan x. You're thinking of tan of x as sine of x over cosine of x. And if so, how would we find the derivative of this fraction? Well, kind of a pain. Probably have to use the quotient rule. I would have to low d high minus high d low over low low. Different ways of writing cosine of x being squared on the bottom. But what I'm going to have for my derivative is cosine squared of x, which is another way of writing that, minus negative or plus sine squared of x over cosine squared of x. And you know trig identity, one of the two that you need to know. You need to know the trig identity that sine squared plus cosine squared is 1 over cosine squared of x. We have found the derivative of tangent. Now, this is written differently when you look on the table that we're going to refer to shortly. We know 1 over cosine is secant, right? So this is 1 over cosine, or secant, times secant. So I'm going to call this secant squared of x. That is the derivative of tangent. Now there is a table, page 144, of derivatives of trig functions. The one other one you need to know, sine, cosine, tangent, and you need to also know that the derivative of the secant of x is equal to the secant of x times the tangent of x. So those are the 4 that you need to know. Cotangent, cosecant, maybe they come up on a homework assignment. If so, you're probably going to refer to these tables. That's never going to be something that is asked, however, on one of my assessments, nor on the AP in May. Now, where's the tangent line horizontal? And I'm going to say that we want to limit this to the domain from 0 to 2 pi. Well, what does tangent line horizontal mean? It means the slope or the derivative would have to be 0. So let's work on that derivative. I would have to take low d high, derivative of cosine is, minus high cosine And the derivative of the bottom, derivative of 2 is nothing. Derivative of that is cosine over low. And I would want to set this equal to 0. Well, all right, now, any fraction. Any fraction is equal to 0 when the top is equal to 0. The bottom here will never be equal to 0. Sine at the smallest is -1. So, yeah, this down here will always have a value. But I want that numerator to be 0. So if I distribute this, I'm going to get -2 sine of x minus sine squared of x minus cosine squared of x. It's got to equal 0. So this is -2 sine x minus, parentheses, sine squared plus cosine squared. And that is equal to 0. And I think we can see that that's going to be 1. So -2 sine of x minus 1 equals 0. -2 sine x is equal to 1 when I add 1 to each side. So the sine of x, when I divide by -2, the sine has to be -1/2. Now, do you know the unit circle? Do you know where that happens? Where's the sine? Where's the y value, -1/2? If you are thinking that happens when x is, again, on this interval between 0 and 2 pi, 7 pi over 6 and 11 pi over 6, then you do indeed know your unit circle. This is a no calculator type problem. And so we have found on our domain of 0 to 2 pi where the tangent line is horizontal, because we know how to find the derivatives of trig functions. All right, we finish up trying to find the derivative at a particular value of x. So we need to find the derivative. We'll find the derivative with x's. And the derivative of this guy, I think we are going to see pretty quickly. Find the derivative of that function, we're going to have to use the product rule. So we're going to find f prime of x, and once we have, we'll replace all the x's with pi over 4. So we'll take, let's see, product rule is first 2 cosine of x times derivative of the second cosine of x plus the second, which is sine of x, times the derivative of the first. And the derivative of this guy, well, let's see, 2 is a coefficient that comes along for the ride. Derivative of cosine is negative sine. And now, we're going to get rid of all of these x's. You could try to simplify. I don't think it really does simplify. But you could try. There's really no need to. It's just time to say, all right, now that I've found the derivative, I am going to replace my x's with pi over 4s. And I know my unit circle. 2 cosine pi over 4. Cosine pi over 4 plus sine of pi over 4 times 2 times negative square root of 2 over 2. And this 2 might cancel with that 2. And so I'd have 2 over 2. This 2 might cancel with that 2. I'm going to have negative 2 over 2. I think I'm going to find that the slope of this function at pi over 4 is going to be 0. I'm going to graph it on my calculator and double check. But that's how we could use product rule in order to find the derivative of a function involving trig. All right, let's take advantage of an opportunity to practice that this evening.